Hello everyone, welcome to Stay Creative. Today I'm going to be making a photometer which can measure the intensity of the light. Let's go! There are a lot of measuring devices to measure various physical quantities like measuring tape for length, physical balance for mass, and stop clock for time. These physical quantities are often represented by units. For example, length can be measured in centimeters, meters, and kilometers. In microscopic level, it is measured by nanometers, micrometer, and Armstrong. Astronomical distance are measured by astronomical units, light year, parsec, and gigaparsec. Like this, in photometry, the intensity of the light is measured by lux. And there is a device named photometer which can measure the intensity of the light. Today I'm going to be making one such photometer which can measure the light intensity in an arbitrary unit. When we include light to our project, we have to include another important component, LDR, to our project. LDR stands for light dependent resistor. The resistance of the LDR depends upon the amount of light that falls into it. At extreme darkness, the LDR becomes almost an insulator. When the brightness increases, the resistance gradually decreases, which implies the product of the brightness and the resistance is always a constant. If we can find the resistance of the LDR, then we can say how bright the light that falls into it. In order to complete our project easier, I am going to be using Arduino. I then connected the 220 ohms resistor and an LDR to my Arduino as per the circuit diagram. I programmed my Arduino to print the analog read of the pin A7. After I open my serial monitor, at little bit darkness, the analog read value is almost 0. When I gradually increase the brightness, the analog read value also increases. The analog read value of the pin is around 0 to 800. Let's keep all these concepts aside. In order to make our project a little bit complicated, I decided to use servo motors as my display. When the analog read value of the pin is minimum, the servo's position must be 1 degree, and at maximum 800, the servo's position must be 180 degrees. Then we can write the analog read value of the pin is equal to the product of some constant and position of servo, and the value of the constant is same for all the positions of the servo. By substituting some known values, I got the constant to be 4.44. In order to get little bit accurate values, I decided to use two servo motors which can display value of two different ranges. By keeping all these concepts in mind, I started programming my Arduino. When I shine the torch on my photometer, it starts showing some value. Now let's find the intensity of my mobile flashlight. I got a maximum value of around 470. Now let us try to find out the intensity of various bulbs of known power. Did you notice something? The intensity of 9 watts LED is greater than 20 watts CFL and 60 watts bulb. Now let's try to find out the intensity of the sunlight at the different times. You got some ideas from this project. The main objective of this project is not only about making a photometer, but also about making a measuring device using a servo motor. If you didn't subscribe to Stay Creative, just click over here to subscribe. Follow Stay Creative on Facebook and Instagram. Links are given in the description below. And finally, thanks for watching.